Hi everyone. I'm not Raoul. My name is Joel, and I was Raoul's one of Raoul's Oracle mentors when he did this internship at us this summer. So I'm here to talk about Raoul's platform for studying language features in Java. And I'll start with a couple of disclaimers. I might be saying we a lot, but I should claim very little credit. So when I say we, I mean Raoul, mostly. And I had one more disclaimer. Can't remember it. So yeah, here's the big Oracle disclaimer. Don't trust this for making money, basically. So Raoul is doing a PhD at Cambridge. My name is Joel. I work in the LangTools group at Oracle. Currently, I'm doing work on annotations and reflection. And also helping Raoul was Alex Buckley, who's also in the LangTools group and is the spec lead for Java. Raoul did an internship at us this summer designing this project. So the questions he wanted to be able to ask and answer was, how do people use Java features? And as a language designer, a language developer, how can we take that information and help making the language evolve? And it makes sense that he did this. For us, it makes sense to getting help from him answering those questions, or from anyone. From the LangTools perspective where I work, these are sort of very relevant questions because we are in the business of evolving Java. So it was fun having him over. So today there are a couple of ways to get this feedback. You can go to conferences or user groups, for example, talking to people. I suppose you could do data mining on Stack Overflow, see what people ask, what are the problems, how do they solve them. You can follow the mailing lists, and the way Raoul explored, or we explored, is what's called Corpus Analysis. So Raoul's definition of Corpus Analysis is apply program analysis on a representative set of software, mine insights from it about features, and hopefully test impact of a new change. I see it like collect lots of software, analyze them, and then profit. That's my idea. And this is useful, we claim. It has been used, for example, in JDK 7. When we did, or when Joe Darcy did Project Coin, we we started using type inference in the diamond operator. And that had a couple of corner cases, and we modified, or they modified Java C in order to try this out on a number of programs and see how often you would hit the corner cases. Also, there was the more precise Rethrow analysis that they did in order to figure out if we would break programs with a source incompatible change. And for Java 8, we are considering a more aggressive type inference, and that as well we can examine if this will lead to problems using Corpus Analysis. Also, I think this is, I think Raoul did work on this specifically to identify if there are unused or very lightly used features that we can possibly deprecate. That would be very helpful, having a corpus to do that analysis for us. And in general, to be able to gather insights about programs out there. It is hard as a language designer and a language evolver to know how people use our programs. And the better we know that, the better we can make decisions for evolving the language, basically. And here are a couple of recent papers, I think, that have used corpus analysis in order to study languages. So, for example, overloaded methods. Yassi et al. I'm not in the research business. I don't know them, but they did an analysis of a lot of code, and on their sample, they concluded that about 25% of overloaded method calls in constructors was there to implement default arguments. That is a pretty strong case to perhaps change the language to introduce default arguments. Another example, and I think this is pretty famous, here's the more precise rethrow. In Java 6, this was legal Java source. In Java 7, it turned out that the first line that says source incompatibility 1, there, before you would throw an exception of type foo, in this case, you knew that you would throw an exception. In 7, you know that you will throw an exception of type daughter of foo, which means that the catch part becomes unreachable code. It will never execute. So in Java 6, this would compile. In Java 7, this won't. So they did an analysis trying to find out, is this a real problem, or is this just a corner case that won't happen, basically. Right. So the problem with corpus analysis are a few. It is time consuming. It's kind of difficult to gather a substantial amount of software and having it compile. That takes a lot of time. And then there is the problem that today you have to be a compiler hacker in order to do the analysis. You have to be able to modify one of the compilers out there in order to write your plugin that will give you the data you need. So it's time consuming it's a time consuming business, basically. And also, if you want to do this on a large scale, which from our perspective in the Line 2 group we would love to do, it also requires a lot of reporting infrastructure. Perhaps you want to do this automatically. When you check in a new compiler, you can see that it handles the properties you're interested in the same way, and that sort of stuff. And that requires infrastructure. His solution and the project he has been working on, and we have been working on, is a solution to a few of those. So the idea is that it should be easy and possible to query this corpus without hacking the compiler. You should get immediate feedback, like you're used to today, and it should be good looking, and it should be easy to analyze the data. And Raoul also wants to democratize this facility, to be able to let people do this online. And I think that's a good idea. I think you still have to have some prior knowledge in order to make this useful, but having this project out there will enable people to start trying this out and have them learn to do this, which will generate more compiler hackers for us to hire, basically. So we set out, or he set out to actually sort of do this and try this. So I have a demo that just like 5 minutes ago started crashing. So it isn't as pretty as it should be, but the demo shows you how to query for use of wildcards, overloaded methods, and covariant array assignments. And this is something that isn't that easy to do today. So I'll try to make this work. Oh. I wonder if this will. Ooh. So this is the covariant assignment. The Corpus tool he has built has a sort of two-part query, and I'll go into more detail about that. But on one hand, you query about the structure of the source, and on the other hand, you also query about the semantics of that structure. So in this case, the query says, find me array assignments and that's the structure, and where the right-hand side is a subtype of the left-hand side, and that's the covariant array. And it turns out it's not that common, and in the projects we have indexed, I think there are, this was supposed to show me how many occurrences there were, but the demo devil ate it. But yeah, so at least we got the snippets. So this shows us examples of this. In this case, the left-hand side is a record array of some sort, and the other one is blank record array. Seems to work. So this is what he has been working on, and I'll see if I can get the overloaded methods to show something. Well, it says that in the projects he has indexed, there are 3,000 methods overloaded. And we were supposed to get a nice graph of this, saying that almost all of them had the name of visit. I guess it's the visitor pattern. Oh well. So yeah, and here's a backup slide of the demo. Right, here's the what's it say? The method overloads. Yeah, so all of those are almost all of those are named visit. And so this is the Java Corpus tool, and we hope, obviously, to make it less crashing and better. So this tool consists of a backend, a database where we store the corpus, a report generation that is obviously a little bit broken, and soon to come a query language that Raoul calls Wiggle. I actually don't know where he got that name from. And the query language is the part that is least finished. Here are a bunch of questions that we sort of have to, or he had to answer along the way. But how expressive should a query language be? What questions, what type of queries are you supposed to be able to do with it? And these are all as of in Wiggle, not yet sort of decided. But he went out there and started investigating the current query languages and checking to see would they support his use case. So he got out there and found seven query languages that already exist to query Java language features, and he made 6 use cases that are sort of typical for for this, and started to examine if the languages would be able to express his use cases. And the results are mixed. So the ones he examined were JTL, BBQ, SOUL, jQuery, QL, Jackpot, PMD, XPath. And here are some example syntax of the respective language. And they're like, it's a mixed bunch. They contain a lot of different paradigms. For example, Jackpot is pattern-based, and jQuery is logic-based. So the first use case he wanted to study was find overloaded methods with multiple parameters that share a single type. And this pattern is interesting because this suggests that the writer of the code should perhaps use the varg feature instead. And also it is necessary to do this. You know, you need to be able to bind variables to the types in the method signature and refer back to them in the semantic query. The second use case was find generic constructors where the type parameter to the constructor has a type relation to the type parameter in the class. And this is another corner case of the diamond operator. It can't handle this. The inference rules, I think, currently break down. So this is forbidden in Java 7, if I understand this correctly. And this also involves pattern matching over types, and also, or binding and understanding the typing relations in the language. And then there were four more use cases. Sort of the fake mutable lexical closure pattern, where you use an array with only one element in order to be able to mutate your lexical bindings. Finding capture conversion idioms. I think this is his favorite. Finding use cases of what? No, that's another. All right, yeah, finding covariant array uses, and also the Rethrow assignment. And the results were mixed. SOUL and QL, they could express all his use cases. Jackpot can express 2 out of 6, the generics constructor plus the Rethrow. And the rest of them couldn't express a single one. Basically because lack of variable binding, no sort of good AST support, too limited information about types, and no filtering mechanism. And for example, SOUL was rather verbose. This is the final array with one mutable array element case. So this is based on the Eclipse compiler internals. So as a query language, it's perhaps a little bit too verbose. His Wiggle query language has the idea that you should decouple the structure from the structural query from the semantical query. So, and I think almost every query we came up with, you had the ability to say, I want to match this kind of source construct, and I want to bind variables to different elements in that source construct. And then I want to do and also semantic filtering over those those variables. And this is work in progress. So here's what he hopes that the covariant array query will look like. I've already explained that. And this is the method declaration, overloaded methods. All right. So here he selects a method name, a type, and a variable name from all method declarations. And on those tuples, he does the semantic query that the method is overloaded and that the type in the parameter list is string. So this would find all overloaded methods where the type is of the parameter is string. And there is a lot more to do, basically. So one thing that we would like to be able to do is, suppose you're changing your compiler a lot, and you want to be able to run the old compiler and have it execute or say emit a lot of properties about the source code you just compiled, and then you change it and you want to do the same thing. And here the open question is, will this language that Raoul is designing, will it be at all useful for that kind of query? We don't know that yet. So that's the query language. The model was, there are a couple of ways to represent the source code. These are all the query tools that he investigated. They had, I think, examples from all of these, at least the XML and relational database way. And they all have pros and cons. So in the end, we considered doing the relational database model, and then we would have to sort of hack our own support for recursive queries, and there would be a lot of joins in that relational database. And it turned out that if we choose a graph-based database, I mean, an AST, that is a graph. So you can just take the syntax tree of the source code, throw it into the graph database, and then you add a bunch of relations like type information. That's just a relation. String has a subtyping relationship to object. So you take your abstract syntax tree, you throw it into the database, you add type information, and you're basically done with the model. And you get graph traversal for free, which is very useful, and also you get transitive closure operations, which turns out to also be useful. So we settled for Neo4j, which is open source, scalable, has a Java API, and it has a query language. And currently the demo, the only thing, the demo is sort of, it's the real deal. It uses the model that we intend to use. It has the front end that doesn't give you the bar charts you want, but the query language isn't done yet. So we are using the Cypher query language instead. And it turns out to be fairly straightforward to do queries. So here's the architecture. You have the corpus. In this case, there's 3 projects. You index them using a plugin in Java C. And, well, the idea here is that we write the plugin one time, and then you can just reuse it you don't need to write your own plugin. We take the syntax tree, we throw it into Neo4j, and we index it. And then we can do queries on it, basically. Here is part of the compilation, the AST for I think it is, doesn't say. I think it is string. So you have a compilation unit node which has a lot of import statements, and that encloses a class deck that has modifiers, and in turn then you can get down to, for example, you declare methods, and that can enclose, for example, wildcards that encloses that has bounds, for example. So this is the this is how the data model look like, and to query this you just need to follow these relationships. If you're interested in find me inner classes, well, that's a lexically enclosing query. So you follow enclosing paths in this graph. And if you're interested in type queries, well, then you follow a different relationship in the graph. So going forward, he plans to continue working this to finish Wiggle, finish the reporting features. We need to fix the performance. Currently, it's quite fast to do the querying. Neo4j seems to be really fast on querying. We haven't been able to index fast. Those 3 projects that we use, there were 400,000 lines of code, and it took, I think, 30 hours to index them. And that's a bit, might not be that useful yet. We hope to open source this. Lawyers haven't had their final say yet. And in that case, we'll make it a JavaNet project and gladly accept outside contribution, and in order to improve this, basically. So, and that was my last slide. So, any questions? Yep.
What are the sample code bases that you're using? Are
They were, let me see. POI, which I don't know what it is. PMD, which is a query language in itself, and then HSQLDB. Those are the ones that we indexed. We also tried indexing Java-C when we developed this, or when he developed this, and that was a bit too small. But I think we found like 3 cases of covariant array assignment in Java-C. That wasn't that interesting, but so those are the 4 code bases we've been working on. Yep.
So you said you were a plugin for Java-C. Is that some sort of, I mean, how do you do that? Is there an API for that?
So the question was, we wrote a plugin for Java-C. How did we do that? And there is not yet an API that we could just use for that. There is a listener mechanism that you can plug into. But what we had to do was, so we inserted a new compilation stage, basically. But hopefully there is a plugin API coming. That's a hopefully that you would be able to. So there you can say, I want to plug in at this stage of the compilation, for example. And it turns out that this is also necessary for, or might be necessary for other projects. For example, the checkers framework, they also need to plug into the compiler in order to run the checkers. So we might be able to combine those ideas into one plugin API. More questions? Okay, thanks for coming, and oh no. Ah, well, the demo devil. Hope you can soon find a project on java.net and start making your queries.